This is a quick example on one way to form a Knowm BS-AF-W Memristor. As you can see, I have my little proto board here. I've had this since high school. Highly recommend this to everybody. Wonderful little prototyping tool. And simple two-channel oscilloscope, nothing fancy. We have a variable sine wave generator here. We have it set to about 700 hertz. Amplitudes at 0 currently. And we're putting the signal across the memristors. So the memristors here are available on adjacent pins, the polarity pointing from left to right. So essentially a voltage applied across from left to right, where the right is the lower potential end, will cause the memristor to go into its high conductance or low resistance state. Now that is in series with load resistor. We have 100 kiloohms here. And we're tapping the input signal and the signal across the load resistor here. And those are displayed on the two channels on the oscilloscope in XY mode. Okay, so this is going to allow us to see the hysteresis loop, which is indicative of a memristor. What we're going to do is gradually increase the amplitude of this sine wave. We're going to monitor the hysteresis loop on the scope. So as we increase this, you'll notice it is just a resistor, very high resistance resistor, low conductance, until we hit the threshold, and boom, there we go. So the memristor, the pathways have been created, and it is now sprung into life. This is in the forward ion conduction mode. This device also has a reverse ion conduction mode and phase change mode. It's a very interesting device. You're going to want to keep the voltage under 1 volt, ideally, to keep it in this forward ion conduction phase. Now, as you can see, we start off on the sweep. We're in the low conductance or high resistance state. We hit the forward adaptation threshold, and we start to increase the conductance of the memristor, decrease its resistance until we hit the low resistance state, and then we sweep down until we get to the reverse adaptation threshold, and that'll take it from the high conductance state back to the low conductance state, and the cycle repeats. As Leon Chua, the theoretical inventor of the memristor, has said, if it's pinched, it's a memristor. This is true for a number of devices. What's special about this device is that it has lots of intermediate resistance states, and it can be controllably incremented between those states in both a forward and reverse direction. In other words, it's an ideal learning device. That's it.